In the last video we made this basic calculator user interface by dragging and dropping items from the toolbox onto the form, setting some properties down in the bottom right, and then double clicking all the buttons to add event handlers to the form's code, and then making regions to tidy things up. So we've grouped the methods into sections. These are all the button click event handlers. In this video we're going to start linking these up to actually do things, so we'll get straight into that, starting with the CE button, which is this button here. When the user clicks this button, we're going to just clear this text box because we want to remove any entry that we are typing. So this is called user input text down in the bottom right here. So when we click this button, so you can double click to jump to the function, we want to clear the user input text. So to clear the text box, simply type this, which is referring to this form. You don't have to, but when I access properties on a class, I tend to start with this, so it's obvious to the reader that it's part of effectively the place where it's in, so it's in form. So this dot user input text dot text. So this is the object itself, this is the text box, and then there's a property inside of this called text, which says gets or sets the current text in the text box. So that's what we want. So text equals, and we'll do string.empty, which is basically a blank string. You can just do two double quotes, which is also a blank string, but again, for readability, this looks much nicer. We'll then comment this function and say clears the user input text. The sender and event are just the event parameters, so we're going to ignore those. So the event sender, the event arguments. Comment the line of code as well. And then we'll just press F5 to run, and let's check this basic function works. So here's the basic calculator. We'll type some stuff, press CE, and you can see it clears the text for us. Now it would be nice as well that every time we're clicking buttons, really the only point of this calculator is to type in here. So these buttons are to assist features, but now we click here, then we start typing. We're now not typing anything. Really, every time we click any of these buttons, we want to set focus back to this text box so that we can continue to type. And if we're clicking these buttons to enter numbers, we can just carry on typing on the keyboard. So let's add that feature as well. And because that's going to be reused for every single button, so every button that you click is going to do a certain action, then we want to focus back to here. Now instead of writing the code that focuses this text box over and over and over for every button, we'll just make a little function that we call so that the code that actually does the focus is only ever written once in the code, and that's something that you want to be aware of when you're writing C# code. It's called dry, which just means do not repeat yourself, and you want to try and keep that as much as possible in code. You want to have as little repetitive code as possible if it's able to be abstracted into another function. So down at the bottom we'll make a region called private helpers, and that's just again a convention I tend to use for private methods, but functions that are very small and the sort of self-contained, and the purpose is to help other functions within this class. So call this private, we don't need to return anything, and we'll say focus input text. We don't need any parameters, so open and close the parentheses, open and close your curly brackets, give this function a comment, and we'll say focus is the user input text. And now to focus that box, I believe it'll be this dot user input text dot focus. Now sometimes you'll find this might not work, and we might have to do some trickery to get this to work, because in this function when you click the button and you let go, this is running on the UI thread, which is the thing that handles all the UI. So if we tell it in here to focus another UI element, it might not work because we're still in the UI thread, and it might need to be released in order to work. So we'll see how this goes anyway. So we'll just comment this function. And let's see if this works. Type something in, click clear, and it's worked nicely. So you can see now, as we're clicking this button, focus instantly goes back to the text box. So we can just type, click. So that's exactly what we wanted. So that's the first function done. Now, these will be really quick and easy. The delete will leave. We'll just whiz through these because these are just inserting. In fact, every one of these except for the equals and delete is now a simple case of adding a specific piece of text to wherever we currently are. So let's whiz through these. Start with the 0. That's a simple case of this dot user input text dot text, and we want to insert. So you don't want to do the text, you'll notice, is just a string. Now you don't want to do text plus equals and add, say, a 0 to the end of the string, because you want to add this, really, you're expecting to add this wherever you're focused. So if we run this quickly, and we were typing, say, 56.7, oh, hang on, no, I wanted 560. Click back here, you click the 0, it's going to add it to the end. That's not what you're expecting. So we want to find out where this cursor is, where the user's input currently is, and we want to insert the value at the start of that. So to do that, we want to do, I believe on a string, you can do an insert, which you can, and that expects the position within the string starting at 0. So if we have a string hello world, oh, if I could spell, there we go. And this isn't valid code, by the way. Well, let's make it valid code, actually. rs equals. So there's a string. And if we wanted to insert, say we were focused here, and we wanted to insert a 0 at that point, that would be index. So starting here is index 0 at the very start. Index 1, index 2, index 3. And then if you press 0 now, that's where index 3 would insert. So what it means by an index is the position in an array, because a string is an array of characters. So this is the first element, this is the first character, second, third. And because it starts as it's called a 0-based index, which means the first character is at 0. It's at the very start. It's not at 1, it's at 0. So if we said insert at index 0, that's going to insert it before the H. If we insert it at 1, it will be after the first letter, then 2, then 3. So the index is the position where we want to add this number. So to get that index, well, let's just start with hard coding this. Let's put 1 for now, just so you can see what happens. So every time we click this button, it's going to insert a 0 at what should be the second character. So after the first character every time. So we type hello world and we click 0, it should go here. So if we click, oh, and you can see something's not right here. And you see here, so this insert function, it doesn't actually set this text. If you hover over it, you can see it returns a string. So it says string.insert. So remember, the first value is the return type. So if you hover over text, you can see the first value string as a return type. So this function is actually inserting this value into the text string, but then it's returning the value, and it says returns a new string. So it's not replacing this text, it's simply returning the new text. So what we need to do is actually set the text to the result. So we just copy and paste that. So stop the code. So this .user input text.text equals, and then it's the text that we currently have with the new value inserted. So you're saying effectively the text needs to be completely reset by this brand new string that's created by inserting some value in there. So remember, the thing on the left side of an operator is set to the value of the right side, and because this insert returns a string, that's what gets set over this side. So let's run that and see if it works as we expect now. So we type hello world. Ooh, doing well with my spelling today. So we should insert after this H. And there you can see the O's gone there, the 0. And every time you click, it's always going there. So now we want to replace this fixed number 1 that's here with wherever this cursor is currently selected. So to do that, we replace this value 1, and we can say this dot user input text dot selection start, and this says gets or sets the starting point of the text selected in the text box. I believe that's the right one. I might be wrong here, but let's try that. Selection start. F5 to run. So let's type hello. Oh, really? I really can't type today. Right, then hello. So let's press 0 and it should end at the end. There we go. Let's click after the E. Perfect. So that's now working as we expect. So we were typing 56.7 and we realized we wanted to put a 0 in. You click there and there we go. So it's just a preference. Some people like typing, other people will like to just click away at buttons and do this. So that's the 0 done. Now I'm going to be lazy here, I don't want you to be, but just for the sake of keeping the video short, I'm not going to comment all these functions in terms of how we've commented here. Just for quickness. So you should do this, and I think you should do this after the video. And I will do it if we carry on with this on a second video. I'll go ahead and comment everything outside of the video. But we don't need to spend time watching me write comments for every single function. But do not leave them out. It's not good practice. You do want comments. I'm just leaving them out just for the quickness of this video. So to fill out all these functions, we'll just simply copy and paste this value. And now you can also see here's another place where we need to keep dry. So this is only one line of code, but you can see it's quite it's not really complicated, but there is some logic in here. We're doing this dot user input text equals this dot insert, and then a selection start, and then a value. Now the only thing that's going to change between clicking 0, 1, 2, 3, 4 is this value here. So instead of copying and pasting this line of code, because if something ever changed, say you wanted to change the behavior and you didn't want it to insert at the start, you would then have to go through every single function and go ahead and change this value over and over and over and over again. So instead, because this is an action, we want to insert the value into the text box, and this is really the behavior that we're typing here. We want to insert it where we've got a selection, and that behavior might change. It's good to move this into another function. Again, just keeping everything very dry, no repeating code. So let's just cut this with Control X, and let's do a function and call it insert text value. And this function doesn't exist yet, we're about to make it, and we will put the number 0. Now let's make this function. So instead of typing the functions like how we've typed it here manually, you can write the function here, the pseudo function if you will, something that doesn't yet exist. You can click here, and you can either press Control and dot, Control period, like that, and it'll generate a method, or you can right click. Now I never right click, so I'll have to find it in this menu. I think it's quick actions and refactoring. Yeah, so it's quick actions and refactoring. But I just click over the function, or you can also just hover like this and you see this little drop down. That also gives you the option as well. So there's multiple ways. You can press Control and dot, or you can hover over and then click the bulb, or you can right click and click the bulb up there. And this is then giving us the option. This is going to generate a method for us, which it's going to call insert text value because that's the name we gave it. So let's go ahead and just click that. And you can see it's made the function for us. And because there was no defined name here, it's given it a default of V. So sometimes this is useful when you're making really long functions. So say we were making a function that accepted a load of integers and maybe a string over here, and then a float, which will be that, and then a double. And then you wanted to, instead of hand typing that function with all the parameters, you could then just press Control dot and enter. And it's gone ahead and made the whole function name with all the variables, and you can go and rename the parameters. So just an option that helps you create a function. So this one's nice and simple, so we're just going to head and type it at the bottom. So we want a function called insert text value that accepts a string. So scroll down to our private helpers. Let's make another one. Private void insert text value accepts a string we'll call it value, and then we'll paste our code in. Now all we need to do is replace this hard-coded value of 0 with the parameter that gets passed in. So we type value. Let's just whack a comment on this. I know I said I wouldn't, but it's just habit. Inserts the given text into the user input text box. Value to insert. And now you can see that looks much nicer as well. So again, don't forget to comment all of these functions, just like we've commented this one. So we can now really easily copy and paste. And the reason this is okay, this copy and pasting, this isn't violating dry. This isn't multiple pieces of code rewritten. This is simply a function name and then the value that changes. So this is now a 1. So we've got absolutely no repeating code here. This is not repeating code. This is simply calling a function, which we want to do in each case. And then the value is different. So there's no sort of repetitive code. If we were passing a specific thing into the function that repeats every time, then potentially you can move that into the function. So anyway, let's carry on. So we'll just go ahead and copy these into each one of these button events, and then we'll go back and change the value. And so we've got 0, 1, 2, 3, 4. Right, and so that's all the numbers done. The dot, the period, whichever you like. So that's every number done. So we can now close that region, make it nice and collapsed. Hide the private methods for now. And we've got the operator methods. Again, these are exactly the same. Insert value, the divide as a /, the times as an asterisk. You might want to change it to a times, such as that, but a lot more conventionally on the computer, a calculator is an asterisk for times. A minus is a minus, a plus is a plus. Oop. Equals. Now the equals isn't something we insert. The equals is when we act, we actually calculate what's in this box. So for this, we'll just create a blank function for now, called calculate equation. And we can press Control dot and enter to create that function for us. We want to move this away from this region, so just cut outside. And then let's place our newly generated function here. Place a comment. Calculates the given equation and outputs the answer to the user label. And then we'll come. This is when you auto-generate a function, it adds this throw new not implemented exception. And the reason for that is if you accidentally create a function and then you're running it and you're wondering why nothing's happening, when you've got not implemented exception, or in this case when you've got anything that throws, and this is an exception when it's doing a throw, this will crash the application. So it's sort of a hint to the developer that they've forgot to do something. So we click equals, it's going to run this throw, and then you can see it not implemented, and it's going to crash the whole application. So it just keeps, there's nowhere it can go, it's just going to crash. Because we've got the debugger, this is just going to keep breaking into the debugger. But if you don't run it with debugger, so effectively this is run without debugger, and say this was the customer using it now that doesn't have Visual Studio and they click this button, you can see it's going to do this nasty crash, and you can just continue or quit, but effectively that's a crash in the application and we don't want that. So we know we're going to do this function, so let's just delete that for now and we'll come back to this last. So we filled out all the numbers, we filled out all the operators, we've got a link when you click equals to calculate, which we then got to do, and we've got a delete button. So the delete button's the last thing, and what that wants to do is delete the character, same as the delete button on the keyboard. If we place the cursor here and we press delete, the B should go, which it does. So we want to mimic that behavior. We want to remove the character in front of the cursor. So we've already inserted something, if you remember in our private helpers. We inserted a value here in the text, and we inserted it at the selection start. So we want to effectively just delete the character in front of that position. So let's copy and paste that line because it's going to be similar. Now the text equals and the text, and then instead of insert, you want to do remove. And you can see the start index is the same, so you want to remove starting at this index, and then there's a nice simple count. Returns the number of characters to delete. So in this case we want to delete 1. Now you will notice here we'll have to protect this function in a minute. Well, in fact right now let's look at this. So if we click the delete button now, there's no text. So this may well now crash because this is going to try and remove something that is outside of the index, that is not, we don't have that amount of text. Let's see. Press delete. And there you go, argument out of range exception. So what we need to do is first, before we do this function, or this action rather, we need to check if the user input text has at least got one value in front of the selection start, because that's the thing we're trying to remove. So if the selection start is 0 at the very start, we need to make sure that the text is at least 1. So what we want to do is do an if check. So if this user input text and the length, which is the total length of the string itself, the amount of information in there, is less than, and we want it to be the selection start because that's where we're going to try and delete from, plus 1 because we're trying to delete 1 character. So if it's less than this value, we simply return. We don't do this action because there's nothing to delete. So what this does, let's presume we have a string and it is test. And then we have this dot, so this logic is, and let's say we're selected here at the very end of the string. So we're at position 0, 1, 2, 3, 4. So we've got the length of the string, which is 4. If 4 is less than the selection start, which is 4, plus 1 is 5, so it is less than that. So let's check if we went back one, which should be valid. So the length is 4, the index is 0, 1, 2, 3. So as 4 is less than 3 plus 1, which is then up to 4. Well, 4 isn't less than 4, so it's valid, it will delete. So based on a quick check in the your own head and looking at it like that, this looks like it should work fine. So press F5 and let's check if the delete now doesn't crash. So right now the string is 0, there's nothing in there. If we click the delete, it should say if the length, which is 0, is less than the start selection, which is also 0 because we know we're plus 1. So it's going to say if 0 is less than 1, which it is, and then it should do nothing. So that's right. So it's not deleting anything because there's nothing to delete. So now let's check it actually works when there is something to delete. So we type the word test as we did in our quick example. Let's first check that it doesn't fail. So now there's still nothing to delete because the length is 4 and we're at index 4. So when we press delete, it's going to say if length of 4 is less than 4 plus 1, which it is, it should still do nothing, which is right. But now if we select before the T and press delete, it should get rid of the T, which it does. So that's ideal. So now we can delete. We can delete strings. Now you notice one thing we forgot to do here. A delete button now hasn't refocused into here. So remember we said after every one we wanted to do this focus input. So let's quickly stop that and add. In fact, now you can see here, if we're returning, you're not going to then focus the button. We've already clicked and you're not going to end up focusing the button if we return here. So instead, let's just change this logic around. So we only want to do this if that's true, and then afterwards we want to then focus the input. So let's first invert this logic, because now we want to do this action if it's capable as opposed to not. So now we want to make sure, instead of the length being less than that, we want to make sure if the length is greater than or equal to, I believe. Let's double check that logic. So that's fine. That's fine. And that has worked, but now you see we've selected all the text. So let's just do that again. Test, you click the end, and it should delete the T, which it does. So it's working, but you can see now we've got this focus. It's selecting all the text for us, which is not what we want. So now this is where you'll realize it was a really good place to move this logic, as we were talking about, into a function. Because you imagine now we'd place this focus input text, and instead of this function call, you actually placed this logic in here and here and in all of these, which we need to. So let's go ahead and do that. And you imagine if you even copy and pasted the actual code, this line here, into all these functions. Well, now we need to do something more than this, because when we're focusing the text, it's actually selecting all the text as well. So we need to change how this works and make sure that it doesn't go ahead and just mass select all the text. So now we only have to change it once inside this function. If we'd have copy and pasted the code over and over, we would have had to keep going through each one of these and then fixing the code over and over. And this is only, a few buttons. So you imagine if this was a larger program, or something with way more buttons, or more repeating of this code, you'd have to go and correct your code time after time after time after time every time, and it becomes a nightmare to maintain. So here was a perfect example of, even though this looks like a really basic thing we're doing, it was a great idea to move it into a function, because it's a thing we're trying to do, focus text, and we're then presuming this will do the job, but it's not always the case. So when you have an action, something you want to do, and you're just presuming that'll always work, unless you're absolutely 100% sure that it will never not work, it will never fail, it's always a good idea to make a function for it, and then place your code in there, and then if anything goes wrong, you only have to change one line of code and not many. So let's place this in all of these. And then we'll do it in the calculate equation, although we still need to finish this function. Let's just place a little to-do note so we don't forget this bit. So now we've added the focus to every call. Let's go back and just confirm everything works, click all the buttons, and then we'll come back to this issue about the focus also selecting the text. So let's see if it does the same thing when we are, you see we press 5 and then it's gone ahead and selected the text point. And now you can see it's also, because it's selected the text, it's put the cursor back at the start. And I know the issue for this now, and that is because we are replacing this text every time. So the reason this is now, it's okay if we do this and then we click there and we insert a dot, that's fine. But now the function that added that dot, so this insert text value, we're replacing the whole text when we're doing this. So because we've replaced the whole text, the default action in Windows Forms is to then just re-highlight all the text as well as resetting this selection start. So when we're replacing the text now, it's going to get a little bit more complicated. We first need to remember where we were in terms of where the cursor was within the text. Then we need to set the new text, and then we need to reset this selection start so that the selection's back where it should be. And I believe that might fix the issue. So let's make a new variable, and let's call it selection start. We'll set it to the current selection start before we mess with the text. Remember selection start. Whoop. Set new text. And then here we now want to restore the selection start. And I've no idea whether this works. I'm literally doing this live, so we'll see. this dot user input text dot selection start. And now we may want to also remember, you can see here the selection length, because if you have selected something such as this, which will bring us on to another point actually, if we select in here and then wanted to insert a 0, you can see it removes the selection and inserts the character 0. So we'll go ahead and add that ability in a moment as well. But for now, imagine you select the text there and you insert something. You expect that to stay the same and something to get inserted. So, well, in fact, no. Let's just leave it so if something's selected like that, we just force it to be. When you've inserted a value, it's not selecting. There's nothing pre-selected. So all we have to do for that is selection start equals the remembered selection start. And as we were talking about, if they did have this selected and they press 0, you're going to have just nothing selected after that. You're going to be, in fact, there's also a point. If you click here and press 0, so you were at point, let's do this in a variable again to visualize. So if you're in Hello World and you click, say, index 1 here, so you're at index 1 now, then you insert the value of 0. Now you're actually at index 2 because you've inserted this value. So even though we're restoring the selection here, you don't want to be restoring to 1. You want to be restoring to after the inserted value. So now the new selection start is where we were, but then also plus the length of the value we've inserted. So the value.length, because if we're inserting, say, a value, I don't know, 555, and you were at index 1, you insert 555, you want to be at index 1, 2, 3, 4. So you want to be at the start of 1 plus the length, which was 3, of 4. So we remember the selection where we are, we insert this value, and then we reset the selection to being the original plus the value we've inserted. And then finally we want to make sure that there isn't anything selected like this. We just want to be at the point of where we inserted the value. So set selection length to 1. Or 0 rather, we don't want anything selected. So let's run that and see if that's fixed the issue. So if we do 5, 5, then we do a dot, and you can see that looks like it's working quite nicely. Just click in there and add a 7, do a delete. Now the delete isn't working. The delete's still selecting everything. So let's take a quick look. Why did we forget to add the focus value to the delete? Nope. So we have an interesting thing going on here. The delete is, yeah, you see now we didn't do the lot. We've changed the text again here. So we're not doing an insert text value like we are here and then doing this logic. We are removing values instead of adding them. So we've got a point now where we've got two different things that we're doing, and effectively the workaround or the solution is very similar. So when we're inserting text, we're remembering a selection, we're resetting the selection, and this logic here, this thing that fixes that selection issue, is based on the fact that we're doing this here. We're doing the start of the selection plus the value. So we've got two logics going on, because when we delete, we're not inserting, we're removing. So this wouldn't work. This sort of logic wouldn't work. So even though this is very similar, that we want to get the selection start, manipulate the text, and then change the selection start, we're going to have another function, or in this case, very similar logic with just one line for the most part being different. This will be slightly different, but again, this is a case where you could go the extra mile and you could make a single function that asks whether you're inserting or deleting values and asks at what positions and things. But by the time you've done that and made a function that's trying to handle two situations, because this code is so small, it's 4 lines of code, and effectively 2 lines are going to be different out of the 4 anyway, it's a case where you just make a new function for the delete. And even though it seems like you're repeating code, it's a situation that's okay because it's a small function. The code isn't 100% repeated. Yes, we could make it a single function, but the complexity of a single function trying to handle the insert and the delete is not going to be as nice and readable and maintainable as just making two functions that are similar but have a different job. So let's make a new function, because this delete didn't have a function. We just put the code here. So we want to move this logic off into a function called delete text value. And then we go down to the bottom and we call this delete text value. Update the comment to deletes the character to the right of the selection start of the user input text box. And there is no parameter now, so we delete the commented parameter and we also delete the parameter passed in. So we remember the selection start. We don't set the new text anymore. We delete the character to the right of the selection. And now you've got an added benefit here as well. If we're not deleting anything, we don't need to do this below because nothing's going to change. So we can change this logic backwards again to if the input's less than this, return, so do nothing. Let's just cut this line of code and place it at the very top, because basically if we don't have a value to delete, then we do nothing. So if we don't have a value to delete, return. And we couldn't do this before in our function up here, the delete function, because we need to do this afterwards. But now the benefit of it being in a function is we call that function, and even if that function returns straight away here, the logic that then does the focusing is coming after the function. So it's not going to return out of this function. It's not going to stop here once this returns. It's just going to carry on. So now we've got the benefit that we can just return here instead of having to say if this, do this. And in terms of when you write if statements, what you try to always do is if you're doing like a certain logic that's basically a check that if this is true, do this. Instead of doing that, which is the natural way you'd think of it, so I don't know, let's say var I equals 5, and you were doing sort of if I is 5, then do something, and then say you do a bit more code, and you get further down, and then you got another check. Oh, let's see, very similar thing, so and then you do if j equals 6, you do something. And you can see what's starting to happen here. This is called nested ifs. So when you start nesting these things inside of each other, you can see your code gets indented and then further indented. And then you also then have the issue of if you're writing code here, you're trying to remember where you are in terms of inside what if. And then if you just come outside of this if and do some code here, you might think that you were inside this if you just missed this bracket. So what you do with if statements is you try to always have the negative side. So instead of it saying if I is 5, you do this, and then if j is 6, you do this, you want to basically say if I isn't equal to 5, then simply return, because then below this line you know that you're only going to get below here if it is 5. So you've removed the if indent, if you will, and you're back to being here with your code, and it keeps it nice and clean. Then you could go ahead and write the other code, and then you could say if you had the j again, and you could say if j isn't equal to 6, return, and then you're still in the same line. You're keeping your code nice and in line without indents. So always try to reverse your if statements to be negated, that you want to basically return or finish with the if, so that the thing after it is the truth of the if, if you will. You know, what you originally wanted to do comes afterwards. So in this case, we're checking if the length is less, there's nothing to do, so we return. So then once we're here, we know we have got some text that we can delete. So this is sort of the truth side. This is what we wanted to do. This is the negative check, that if there isn't anything to do, return. So that's why we try to always keep this if return. Right, so back to this function. So delete text value. First check we have something to delete. If we do, remember the selection. Now we want to delete the character. So same line of code, same thing. And now we need to restore that selection like before. And this time, because a delete deletes in front of where you've got a selection, so if I press delete here, the S will disappear. You'll notice my index, in terms of from the start, has never changed. So if I start at index 1 here, and press delete, I'm still at index 1, over and over and over. I'm always at index 1. So you don't need to actually add anything to the index, because it never changes when you're deleting in front of the selection. So we remove that value.length. And now we restore the selection to effectively where it was and make sure nothing's selected. So that should now have the same result as all the other buttons. Let's just go back up to the delete button, add a little comment here. And press F5 to run. Let's do 75.6 divide by 5, and let's go. Now we didn't want the point, let's go back, press delete twice to get rid of that and that. This all looks like it's working. We can also type, so we do 55.4, 55.6 divided by 4, and then let's go back to here, 0.5 and space times 8.7. So you can see everything seems to be working nicely. You can plus, you can minus, you can times. So all of the buttons are now working, including the delete button, the C button to clear everything. Everything seems to be nice and functional. So now we almost have a complete calculator here. We've got every single button working. We've got everything acting the way we expect. We can add all these things. Click equals, but that does nothing yet. So hopefully you've seen here, you've got quite a nice, a little bit of understanding about the importance of using functions for code to keep your code dry. Also, we were originally just inserting text like this, and then we realized we had to add this logic around it. And now this function, we press Shift and F12, you can see everywhere that it's used. You can see here we use the function over and over and over and over and over and over. And luckily, because we've used a function and not just pasted that code into each position, we've only had to write this complicated logic once. And the same goes for the delete. We didn't originally have a function, and then when we needed to add this extra logic, it was time to move it into a function. So you've got some private helpers that do certain things. Then you've got all of your button events linked in. You now need to just go ahead and comment each of these classes. So I'll just go ahead and do this now and speed the video up so you can see the complete class. So there you can see everything's nice and commented now in the whole class. So the class itself's commented, the constructor's got a comment, every function has got a comment, as well as the code within it's commented. And as you scroll through, you'll see I simply added a description, adds the specific character to the text at the currently selected position. And then I just copy and pasted this and changed this value, this. Add the times, the minus, the plus, the equals. And again, it might seem laborious, but trust me, this is really, really beneficial going forward. If you're a developer that adds comments, you're much more likely to get jobs. It's much easier to understand your own code when you go back to it. In general, it's just one of the best things you can do. So many developers do not add comments to code, and that's just like selling a really complicated piece of equipment with absolutely no user manual. This is something that most developers don't like doing, but it really is crucial. I can't emphasize enough how much you should comment your code as much as possible. You can't have too much comment in code. So you can see here we've actually got no comment on the insert text value. That's one place you can improve. Again, it says insert text value, but that's code. So what I would write is to say insert the value in the user input text box at the currently selected position. And that's a nice comment that, because we say insert the value, which you can see there visually, so that's good enough, you can now copy and paste this comment everywhere we need to. So you can go through and just really quickly copy and paste the same comment. And now here equals, we can actually notice this is the wrong comment because the equals doesn't do this. So this actually calculates the given equation in the user input text. There we go. And then the same for the numbers, same comment as before, add the value, and then here we want to copy and paste this same comment here. And when I glance through code, I always try to look for effectively black text with no green text above it. And that's a nice, quick, visual way of realizing there's no comment on code. And there's you can see already in this code that we're writing that I don't think there's a single line of code that doesn't have a comment. If it does, it's very rare, like here. And that's really because we've said here focuses the user input, and it's a very singular line of code. So there's, I mean, you can really add effectively the same comment below, but there's a few instances like this where you don't really need the comment here. It's explained here, and then when you look in the function, there's nothing more to see. So it's a very, very short and sweet. But other than that, every single line of code has got a comment, and that's, again, it's a really good thing. So now the only thing left. Let's just do this. See these using statements at the top? These were added automatically by Visual Studio. See how these ones are grey? These aren't used. So you can go ahead and just select them and delete them. And that just cleans up. Again, further cleans up your code, keeps it nice and organised. Now we can go ahead and collapse the comments. So you can press the minus. Then collapse your regions. And then we've got this one function that's left that we haven't done yet. Collapse this region. And then you can see now, so a class that's already 352 lines of code long, if we collapse the regions and the comments, you can nice and easily and really quickly browse through this class and find things and maintain. So if you wondered where, oh, the number 9 isn't working, well, you can glance through your class really quickly and go, number methods, double click, and then you can see all the functions inside of here. And you can just go to the number 9. And there's your function. So it keeps it organized. And when things are organized, it's much easier to work with. So in the next video, we'll finish up this calculator. And we'll do this final calculate equation. So we press F5. If we were then to type, say, 5 times 4 and press equals, we expect this text box here to then have the answer. So we'll start with something really basic like this. Then we can do things like 5 times 4 plus, open brackets, 2 divided by 6.73, close brackets. And that's still a valid equation. Then we need to get into more complicated things, such as handling inside of brackets first, and then working out this value, and then exploding that out into the value of the answer, and then calculating the order of priority of these operators. So by default, in math, the times and divide get done first before the plus and minus, which come last. So we need to look at the order that math equations should be worked out in. Then we need to handle brackets. And then we also need to handle things like somebody does this, and it's not a valid equation. Now, instead of just saying something's wrong, we're going to actually say, if you type 5.4 times 5, f dot 34, and you click equals, instead of just saying that's not valid, we'll actually go ahead and sort of select the text like this. So when the user clicks equals, it's going to actually say this part's not valid. So they can easily see, and they can even then just press the delete key. So we're going to have to do some checking that what they type in is also a valid math equation. So that's going to be quite an intensive video, and it's going to be a lot more on coding than visual. So stay tuned.